Finding square roots is a really important skill that we will need later on this year when we learn the Pythagorean theorem, which has to do with missing lengths of sides of triangles. You'll also be doing a perfect quiz on the perfect squares, which we'll talk about later in this year. For today, we're just going to use the multiplication facts that you guys already know to solve square roots. So the first thing I've written here is that 9 times 9 equals 81. This is called a perfect square. 81 is a perfect square because there is a number that when you multiply it by itself gives you that exact number. 9 times 9 is 81. Also, -9 times -9 is 81 because two negatives, when multiplied together, give me a positive 81. So if I ask for the square root of 81, the answer is 9 or -9, because these two numbers multiplied together give me 81. These two numbers multiplied together give me 81. So we need to remember that every square root has two answers. One is positive, and the other is negative. So here's another perfect square. 36 is a perfect square. The square root of 36 will be something times itself. What number times itself gives me 36? 6. 6 times 6 is 36. So the square root of 36 is 6. Or what's another number? -6. Because -6 times -6 also gives me 36. This down here is a little bit of a typo. This is supposed to say 144. Excuse me. The square root of 144. What number times itself gives me 144? 12. 12 times 12 is 144. What would be the other number? -12. Because -12 times -12 would also be 144. These numbers, 81, 36, and 144, are perfect squares. Now, not all numbers are perfect squares. In fact, most numbers are not perfect squares. What I've shown in these two boxes are all of the perfect squares from 1 to 400. In the first 400 numbers, only 20 are perfect. So perfect numbers, perfect squares, don't happen very often. Most numbers are not perfect. So if I try and do the square root of anything on this list, I get a nice answer. The square root of 25 is 5. Or, as we saw on the last page, -5. The square root of 4 is 2, or -2. So these numbers on this list are perfect, but as I just said, most numbers are not perfect squares. So here's what we have to do when we have numbers that aren't perfect. We're going to approximate an answer. I can't actually find the square root of a non-perfect square without a calculator. We can come up with a pretty good estimate of where a square root will be. So the square root of 50, let me show you really quickly on a calculator. The square root of 50 is going to be an irrational number. You can see that it goes on forever, it's not repeating. But I can figure out the square root of 50 where it is approximately. I'm going to look for my perfect numbers. Definitely 50 isn't there. but it should go right in between here. The square root of 49 is 7, and the square root of 64 is 8. So the square root of 50 is going to be in between the numbers 7. It's going to be between 7 and 8. I can tell because of where 50 lies on my list. What about the number 105? So I'm going to look through my perfect list. It must go right here. The square root of 105 is going to be between 10 and 11. I don't know what it is. It's going to be irrational. It's going to go on forever and not repeat. But the answer is going to be somewhere between 10 and 11. And here's one more. Let's try the square root of 42. Let's see, 42 would go right here in between 36 and 49. The square root of 36 is 6. And the square root of 49 is 7. So this is going to be between 6 and 7. So sometimes you might be asked, between what two numbers is the square root? Well, the square root of 50 is going to be between 7 and 8, so on. But we can go a step further. We can approximate the square root with a decimal. So let me mark right here. Here's the square root of 50. It's somewhere between 7 and 8. Well, what kind of numbers are between 7 and 8? 7.5, 7.2, 7.6. The answer is going to be 7 point something because it's between 7 and 8. Now I need to check if it's going to be a small decimal, like 7.1, 7.2, 7.3, or 7.4, or if it's going to be a large decimal, like 7.6, 7.7, 7.8, or 7.9. The way I decide is by checking to see, is this closer to the low number or is it closer to the high number? 50 is only one number away from 49, so I'm only one number away from the low. And 50 is 14 away from the high number. So the square root of 50 is going to be a small decimal because it's closer to the low number. Closer to the low number. So as an answer, I would accept 7.1, 7.2, 7.3, or 7.4. Let's check on a calculator to see what it actually is. The square root of 50 is 7.07, which would round up to 7.1. Let's try another question. The square root of 105. The square root of 105 goes right here. It's between 10 and 11. And now I'm going to check. Is this closer to the low number? Well, that's 5 away. And 105 to 121. 121, that's 16 away. So this is going to be another small decimal, either 0.1, 0.2, 0.3, or 0.4. So I'm going to write that the square root of 105, it's between 10 and 11. What kind of numbers are between 10 and 11? 10 point something. And since it is closer to the low end, I'm going to choose 10.1, 10.2, 10.3, or 10.4. Any of those answers would be acceptable without a calculator. Let's go ahead and see what it is. Why don't you make a guess before you see the answer? Choose one of those four. Looks like 10.2 is the best guess. Let's try one more of these together. The square root of 42 goes right here. It's between 6 and 7. What kind of numbers are between 6 and 7? Things like 6.8, 6.4, 6.5. So my answer will be 6 point something. Now I need to decide, is it closer to the low? That's 6 numbers away. Or is it closer to the high? That's 7 numbers. So this one also happens to be closer to the lower number, which means I'm going to guess that it's 6.1 or 6.2 or 6.3 or 6.4. Why don't you make a guess? Which do you think is actually the closest? The square root of 42? 6.4. Now, using what we just did, you could also be asked to approximate the square root to the nearest whole number. Well, we decided that the square root of 50 was between 7 and 8, but it was much closer to the low number. So to the closest whole number, I'm not going to use an equal sign, let me erase that. To the closest whole number, it would be about 7. Here's the square root of 105. It went right here. And it was only 5 numbers away from the low end. 105, the square root of 105 was between 10 and 11, and it's closer to the low number, happens to be about 10. And the square root of 42 was between 6 and 7. It happened to be closer to the low number. It's only 6 away from there, so it was closer to the low number, which was 6. Here are 3 more questions I would like you to try. I'd like you to solve all 3 answers. So I want an answer that says that it's between something and something else. That will be one answer. So maybe it's between 13 and 14. I want your second answer to be a decimal. So maybe that turns into 13.8. And then I want your last answer to be, what number is it closest to? So if I had a number that was between 13 and 14, and I estimated about 13.8, then my answer would be that it would be about 14 because it's closer to the high end. I'd like you to have these 3 problems done on your notes, please, tomorrow. Here are 2 different games that you can play. The first one practices the perfect squares, so things like 3 to the second, what is that? The second game practices the perfect square roots, like what is the square root of 121?